Okay, so let us go with a quick revision. Good morning. So, block structure. The block header we have already discussed. The header data contain metadata of the block and in that we have the following things which has to be marked, that is block header include header, that is hash of the previous block header, hash of the current block, timestamp, cryptographic nonce, markly root. So a markly tree is a binary tree formed by hash pointer and named after a creator, Ralph Markly. Okay, so what is exactly the Markly tree comes into picture and do the work. That is, Markly tree is a that is per block tree of all the transaction as we have already discussed. So I am going with a quick revision. A Markly tree is a per block tree of all the transaction that includes in the block. It allow us to have a hash or digit of all the transaction and the previous proof of membership in a time efficient manner. So then we have this diagram which we have already discussed, that is block n minus 1, block n, block plus 1, that is decreasing of 1 and increasing of 1. So when we talk about the header, what are the headers we have? Hash of the block header, timestamp, nonce, hash of block n minus 1, that is n2, that is numbers of elements which we have, and the transaction data, how the transaction has been followed up, that detail has been there. So two things in the blocks we have, that is the number value, that is Markly tree will carries header 5 things, and with that we have the tree structure. So next slide we will have this brief explanation which is 1 minute. Let me zoom this. Okay, so let me have this finger. Oh, fine. So Markly tree structure, see here h of function, and that is called as root, Markly root. See, I'll just highlight with this. See here, this is a h of, that is Markly root. Then we have this leaf node, that is non-leaf node we called, and this one we called as that is leaf node. And this is also h of function leaf node, h of function leaf node. Here also h of function leaf node. Then we have the tree, that is transaction. T is nothing but transaction. Okay, transaction of the leaf node. So here I'm just using this pen. A blockchain can be a potentially have thousands of blocks with thousands of transactions each block. Therefore, memory space and computing power are the two major challenge when we talk about the storage. So in this we have the, it would be that is, I'll just go with this highlighter. See here, it would be optimal to use a little data as a possible for verifying transaction, which can reduce CPU processing and provide better security, and this is exactly with Markly tree offer. So in a Markly tree structure, transactions are grouped into pair. The hash is computed for each pair, and this is stored in a parent node. Now the parent node are grouped into pair, and this hash is stored one level up in the tree. The continued process of the root of the tree it follows. The different types of root of a Markly tree are root node, leaf node, non-leaf node. See, already we have discussed with the diagram. We have following thing. We have Markly root, that is root node. We also called as root node, and we called as non-leaf node. And then we have a leaf node. So the three things, root node of the Markly tree is known as Markly root, and this Markly root is stored in a header of the block. So that means the main header, we have this root node as a header of the block. Then we have leaf node. The leaf node contains the hash value of the transaction data. Okay, with the, we have already discussed about what is hash function, hash value. Each transaction in the block has its data hashed, and then this hash value is also known as transaction ID. It is stored in a leaf node. Then we have the non-leaf node. The non-leaf node may contain the hash value of their respective children. See here, hash value of their respective children, and these are also called as intermediate node because they contain the intermediate hash value, and the hash process continue till the root of the tree. Okay, so let me slide up. So, Bitcoin uses the SHA-256 hash function as we discussed. The hash transaction data continuously till the Markley root is obtained. And then we have the further, a Markley tree is a binary in nature. Always remember a key point, that is Markley tree is a binary in nature. This means that a number of leaf node need to be even for the Markley tree to be constructed properly. In case there is an odd number of leaf node, the tree duplicates the last hash and make the numbers of leaf node even. Okay, then we have how do Markley tree works. So Markley tree is constructed from the leaf node label all the way up to the Markley root label by grouping nodes in pair and calculating the hash of each pair of node in that particular label. This hash value is propagated to the next label. This is a bottom to up type approach. Okay, this is how Markley tree works. This is a bottom to up tree of construction where the hash value are following from the down to up direction. So hence, by comparing the Markley tree structure to a regular binary tree data structure, one can observe that Markley tree are actually inverted down. Okay, then let us talk about this diagram. Okay, so in this diagram, let me take the highlighter. This is a top to bottom approach, binary tree how it forms, and this is a Markley tree how we have used this inverted to bottom to top approach. For example, see here we have h of a, h of b, this example. So when we have a HAB hash function, h of a, h plus h of b, then we have together collaborating this together, we have h of ab plus h of cd. See here, h of c, h of d, then this h of c plus d has been defined as a non-leaf node, and then this one compared with this, it has become a root node, that is h of, I'll just mention here, h of value. Okay, h plus that has function. So example, consider the block has 4 transactions T1, T2, T3, T4. This down we are called as a 4 transaction. This 4 transaction have to be stored in a Markley tree, and this is done by the following steps. See here, step 1, how it is working. Let me take the highlighter. How it is working. See here. The hash of each transaction is computed, h of equal to h of t1. Similarly, h1 is step 2. I think it is visible more clearly now. Okay, so h of this value, the hash computed are stored in a leaf node of a Markley tree h2, and that comes under the step 2. Now step 3, non-leaf node will be formed. In order to form this node, leaf node will be paired together from the left to right, and the hash of this pair will be calculated. Firstly, hash of h1 plus h2 will be compared, as we have already discussed this one. See, I have shown you this is the same thing has been written here. So h12, that is hash h1 plus h2 has been joined together, and h34 transaction h3 plus h4, it's joined together again. So finally we have this structure. Finally, n h1 2 3 4 has computed by pairing h12 and h34. It become h1234 is the only hash remaining. This means we have reached the root node, and therefore h123 as a Markley root. So this is our solution with this diagram. See here, T1, T2 is a transaction, H1, H2, H3, H4 is a leaf node starting of the tree, H12, see here, H12 and H134 is a non-leaf node, and then later on it becomes a bottom to top approach, that is H123. So as we know here, this is an approach of bottom to top. So we have come up with the concluded example. Now we will discuss about the okay. Now we in the next class we will discuss about how this going to be make us as a key point. Thank you.